Hey guys, today we're going to be talking about slope. This is the first section of chapter 4. Here are a couple vocab words, or I guess one vocab word. So you'll want to pause and write all this out in your notebook. Slope describes the steepness of lines in the coordinate plane. It could also be used to describe the rate of change of a quantity. So we think of slope as being the vertical change over horizontal change, otherwise rise over run. That's what slope is. How does something change vertically compared to how it changes horizontally? The slope of a line is going to be the change in its y-coordinates over the change in its x-coordinates, which is also rise over run. So this is a huge thing that we use a lot in algebra. So you'll want to make sure that you really pay attention. Take good notes on this lesson because we'll be using it a ton. All right, let's keep going. Okay, so here is an informative pie chart that I found that I thought would be really helpful for us to take a look at. It says, what do helicopters do in action movies? So anytime you've seen an action movie, you know, a lot of like fighting and cool stuff like that, manly stuff, there's always a helicopter in it, and here's a good breakdown of what happens to those helicopters. Yeah, they explode. Every time. Okay, so positive and negative slope, you read graphs going left to right, and as you read it going left to right, if the slope is moving in a uphill fashion, then that is a positive slope. So you'll want to make sure that you have this written down. If you read the graph going from left to right and it goes downhill like this is left to right and it's going downhill, then that means that is a negative slope. So that's going to be a very important thing for you to know. So finding the slope of a line. First of all, let's identify this going left to right is going downhill. Okay, so it's going downhill, which means it's going to be a negative slope. And the way you read this, if you recall on that other slide, is I'm looking for rise over run, or how does the y value change? This is called a slope triangle. You can see right here, this, and this all make a triangle. So how does this value change? Well, how does it rise? Well, if it's going down, we're going to say that that's a negative number. So it goes down 1, 2, 3, 4. So negative 4. And then how does it change going right or left to right? It goes 1, 2, 3. So it says find the slope of this line. The slope of this particular line is going to be just negative 4/3. Now on this particular fraction you can't simplify it. But if you ever do get one where you can simplify, where both the numerator and the denominator are divisible by some common factor, you need to make sure that you do that. In this case there isn't one. So here's one for a couple for you to try. Go ahead and pause. Take a minute and try finding the slope of both of these. All right, after you've done these, hopefully this is what you get. I draw the slope triangles on here to make it a little bit easier. So this one has a rise over run of 2/5. This one, if you're counting the points, is negative 2/4, which simplifies to negative 1/2. It must be simplified, so be careful with that. All right, so slopes of horizontal and vertical lines. Find the slope of each line. State whether slope is 0 or undefined. If I think about this and I try to do the triangle, first there isn't any triangle. But if I'm thinking of this in terms of rise over run, to get from this point to this point, my rise is going to be 0. All right, I didn't go up anything. So the rise is 0, and then the run is going to be, it looks like 5. But 0 divided by anything is 0. So what this means is that when you have a horizontal line has a slope of 0. This one right here, the run would be, if I look at it as rise over run, the rise is going to be 1, 2, 3, and the run is 0. And since you cannot divide by 0, that is an undefined thing. It's impossible to do that. We call that slope undefined. So a vertical line, one that goes up and down, straight up and down, is an undefined slope. Make sure you take note of that. All right, so go ahead and try this one. State whether it is 0 or whether it is undefined. So on this one, you find that it creates a vertical line, and that means it is a undefined slope. All right, so finding slope from a table. It says graph the fuel usage from the table, connect the points with a line, then find the rate of change. Remember, rate of change is just another way of saying slope. So let's go ahead and graph it. I have this already made for me. So if you graph it, this is probably a good way to graph this one. You got to be careful here because these values are large. So when I put this on here, these intervals are going to be a little bit larger, and these are going to be a little bit bigger than what you're used to, even though the grid may look like this. So I'd copy this table down in your notes. Also get this copied down into your notes so that you have something to look at. It says then find the rate of change. I got this on another slide here, so I have a little bit of room to work with. The rate of change, again, is the slope. So if I think of this, it doesn't matter what point I pick. I'll just pick this point and this point. I want to know, how do I get from here using rise over run? So I'm going to have my triangle. Well, 4 to 6, be careful, I go up 1 unit on the grid, but 4 to 6 is increasing by 2. And then here I go over 2 units, but it doesn't mean 2 units. Take a look down here. I go from 80 to 120, so I'm increasing by 40. So on this one, my rise over run, my rise over run is 2 over 40, which simplifies to 1 over 20. All right, so my fuel usage is going to be 1 gallon for every 20 miles traveled. That's the rate of change. 1 gallon per 20 miles is how you find that. Again, you're just finding slope. So here's one for you to try. Go ahead and take a moment and give that a shot. You want to pause before you do that. All right, so here is hopefully what you found. There's my line. I made the slope triangle. I have a -2 for my rise and a 1 for my run, which simplifies to just -2. So that's the slope for this particular problem. That's it for today. Make sure that you have taken good notes, and we'll be working on this in class.